So first, let's consider the very complex topic of BGP path attribute manipulation. And I want to understand a little bit about what that means and the ramifications of using BGP path attribute manipulation, how to configure some of the more common ones. We're not going to obviously cover all of them. That could be a course all by itself. And then how to verify whether path attribute manipulation is in fact working correctly. First, we want to understand what is intended by the words BGP path attribute manipulation, or BGP-PA for short. We want to look a little bit about what does this accomplish? What kind of scope is there to this particular type of path selection alteration? Well, the first thing to understand in knowing what you can accomplish with this is adjustment of your routing preferences. Remember, BGP does not use traditional metrics, as in the case of OSPF, EIGRP, and so forth. It uses these path attributes, which allow you to be able to tune and change and alter a variety of different things. So adjusting the routing preferences. It can prevent a particular autonomous system being used as a transit. For example, in the diagram to the left, if we so chose, we could prevent either the router 1 or router 6 autonomous systems respectively from being used as a transit, meaning having any traffic pass within it to another location. For example, if we want all traffic to be forced to go from router 1 to the internet router and never use going through router 6 up to the internet router as a path, there are ways to be able to do that. It can also give you an opportunity to create preferences for entry into an autonomous system and out of an autonomous system. Obviously, RLAB is extremely simple, but in looking at the BGP configuration and routing tables and so forth on the AT&T route server, you can see that there's a great deal that can be discerned there about what is the preferred router or routers to use to go into Autonomous Systems 7018 and coming back out of. In service provider networks, this is absolutely critical. It can also give you the ability to be able to allow or filter routes based on a number of criteria, and this is not an exhaustive list, but you can use route tags, the route type or origin, recall, IGP injected, EGP unknown, incomplete attribute, routes to or from a specific autonomous system. Now, one of the things that can be done is called AS path prepending. We touched on this a little bit in our previous lesson. It can lengthen the paths to one or more destination networks. Remember, BGP prefers shorter paths. Look at the graphic on the left. The AS path to 65006 from router 1 is going to be a single AS path hop. In order to be able to get there through the internet router, it's going to be 2 AS path hops. Look at that, 65006, 65000. And then from router 6's perspective, it's the opposite. But the whole point is the direct route between R1 and R6 is always going to be preferred over R1 internet router R6, and conversely, because it's a longer AS path. However, you could actually selectively, for a set of prefixes, lengthen the AS path between router 1 and router 6 so that it prefers to go through the internet router for those prefixes. If you want to, for example, configure load balancing, you can take a set of prefixes and lengthen the AS path so that one particular exit point is less preferred and another is preferred, and vice versa. There are ways you can do this to be able to try to force traffic across different links in another manner. It's never a perfect solution because it's not always going to be 50-50, but it gives you an idea of being able to shift some of the configuration from one preference to another. In order to be able to configure path attribute manipulation, specifically AS path prepending, there's a couple of steps. Step one, first thing you need to do is you figure out what prefixes or group of prefixes do you want to lengthen the AS path for. It may be those originating from a particular service provider's network or a certain autonomous system. I mean, there's a variety of criteria, but you need to know what network or networks you want to be able to do this with. Then construct an access list matching the desired networks. Once you've done that, create a route map with the appropriate match command identifying that access list. And then finally, in the set commands, use the set AS path command in order to be able to have it be applied. Finally, in order to be able to have this enacted or put into place for updates to or from a particular network, add the neighbor, obviously peer IP address, route map, the name of the map, and inner out depending on what you're trying to influence. And another critically important step is once you've made changes on a BGP neighbor, you have to clear the relationship for the settings to take effect. The easiest way to do this is the clear IP BGP star command, which resets all relationships, although you can do it selectively by neighbor or by autonomous system. So keep that in mind. Always make sure you clear your neighbor relationship for it to take effect. Now, one of the things that you can do for AS path filtering, which is different than AS path prepending, it's kind of the opposite. Prepending is actually changing something specific. Path manipulation is actually trying to filter out certain things. So the AS path filtering uses a configuration technique called regular expressions. If you've done a lot of Linux and Unix programming, these are probably very familiar, but it might be newer to you who have just been, traditionally route switch people. So there are several characters to keep in mind that you can use in your regular expressions. The period or dot matches a single character. So if you only wanted to match AS path numbers with 5 numbers, you could do ... just as an example. You can use brackets to match a character listed in the brackets. You can also use the brackets together with the dash to match an entire range. The caret symbol, and these are the next two are very important. The caret symbol is the start of the regular expression, start of the line. The $ is the end of that particular line, so keep that in mind. And then the underscore matches a comma, beginning of the line, end of the line, or a space. So these used in combination can actually give you quite a long way of being able to filter out things by AS path. And remember, by AS path, the examples are to the left, just in what we've talked about before. The AS path, for example, to 65006 from 65001 is either going to be 65006 because that's the originating, or it's going to be 65006, 65000 coming through the internet router. Now, it's helpful to actually look at some practical examples of the regular expressions type of combinations in order to be able to see just how the effects that it can have. And here's just some common ones. The dot and star means it matches anything. So it's kind of the match any in accessless terminology, just as an example. If you just want to match all locally originated routes, you do the caret symbol and the $. Remember, that means the first character and the last character, start of line, end of line, which essentially means match an empty string. If it's locally originated, there are no AS path parameters really at all. So it's just saying match just locally originated routes. Now, just an example using some of the parts of our lab, if you only wanted to learn, for example, from the internet router or router 6's perspective, you only wanted to get local routes from AS number 65001, you do the caret 65001 and the underscore because it would match anything that's being learned from that. Because keep in mind that wherever AS something is originated from, that AS number will come last in the string. If you want to match not just routes learned from AS001, but originating, because it's the last one in the path, the 65001 $, because it's saying that that's the only thing that's going to be coming through, because routes learned from that will end in 65001. And then any route originating from or passing through 65001 would be the underscore 65001 underscore, because it'd be occurring in the middle, just as an example. So to configure AS path filtering, again, always start with what you're trying to filter so you know what you're working with and what your targets are. Then construct a regular expression that identifies the path. You can actually do the show IPBGP regular expression, REGEXP, and test out different ones so you can figure out which one you want. Then you're going to create a very special kind of access list called an AS path access list. It's unlike a standard access list. Its only purpose is to be able to match a string of regular expression characters. So you use the IP AS path number, access list, permit deny, and then the regular expression commands within it. In order to be able to apply the filter list, you do the neighbor IP filter list, in or out, with the access list. And then once you've done that, remember you use the clear IP BGP command in order to be able to reset the particular neighbor or neighbors that you're trying to apply that filter list to. One of the other path attributes you can use to influence routing and choice of a particular route for a particular prefix is the weight attribute. Now, technically, it's not a path attribute. It's a Cisco proprietary configuration technique, but it essentially acts like a path attribute. If you want to set the weights for all routes coming in from a particular peer, in other words, you want everything that comes from that peer to be chosen first, you can use the neighbor peer IP wait command. And then anything that's coming in is going to have the wait reset to whatever you have it set for. Remember, the higher the number, the more preferable. However, if you want to use selective, which is probably going to be more likely, use of the wait attribute, first create an access list so you can identify the routes. Again, access list command. Then configure a route map. In this case, the route map is going to use the match and then the access list command. And then the set designation is going to be something between 0 and 65535 to give you the wait command. Then once you've constructed the access list and the route map, then you apply that again to a specific neighbor doing the neighbor peer IP route map in command. Because from the perspective of the router, you want to be able to have the routes coming in from that neighbor to have that particular wait attribute set. And again, remember to reset your peer relationship doing the clear IP BGP peer command. So we've looked at AS path prepending, AS path filtering. We've looked at how to change the wait attribute, but we've also talked about, if you recall, if you want to influence outbound routing from within an autonomous system among iBGP neighbors, you use the local preference command. And if you want to be able to signal to directly connected neighbors, peers, they don't necessarily have to be directly connected, the preferred ingress point to autonomous system, you use the multi-exit discriminator. Well, the syntax for both of these is identical for local preference and multi-exit discriminator. So keep in mind that the only difference is going to be the direction in which you're going to apply it. Multi-exit discriminator is going to be out to the neighbor. Local preference is going to be coming in from the neighbor, much like the wait command in that aspect. So again, you start off with an access list, know what it is you're trying to influence. Use the access list command, or you could use an AS path access list to identify the neighbors for that command. Create a route map, match AS path access list, in this example, for specific networks. If you want to set the multi-exit discriminator, you need to use the set metric. Now remember, metric is not really what we consider the actual metric as used in other IGPs, or an IGP specifically, because BGP is not an IGP. But set metric and the value. The lower the value, the better. That's the one thing with the multi-exit discriminator to keep in mind. The lower value, the better. With local preference, the higher value, the better. So set metric for MED and set local preference for the local preference setting. For setting the neighbor relationship, you do the neighbor, address, route map, the name, and in this case for the multi-exit discriminator, remember it's going to be out because it's being advertised to that neighbor what the entry point into the autonomous system is. And obviously local preference would be the opposite. To verify how these path attributes have been altered, you can use a number of different commands. Again, show access list, remember, make sure it's non-zero. Show IP BGP. This is the easiest way to be able to verify whether your AS path prepending, for example, is working correctly. You will see the additional autonomous system numbers. For instance, if it's coming from 65001, you should see multiples of 65001 depending on how many you specified to be prepended. You can do another command that's very powerful is just show IP BGP neighbor, then the peer IP of the neighbor, and then received routes. This is a great command because it'll tell you specifically what commands are being received from a particular neighbor. And you should see the prepended AS numbers in that as well. You can do the show IP route BGP and verify that the route that you altered, in other words, you are shifting preference from one route source to another, make sure that the next hop address, for example, is pointing to the other neighbor whose path you've made more preferable. For verifying AS path filtering, show IP BGP neighbor received routes. Again, you're going to be able to look and see what's coming in. And remember, the preferred route's going to have that greater than symbol. Look for that and make sure that the desired routes are there and that they've been selected as preferred. You can do the show IP route BGP. Look at the next hop neighbor address. Make sure it's the neighbor relationship that you wanted preferred. To verify the wait attribute configuration, do show IP BGP, and it's going to list all of the elements that you want. It's going to show the specific integer that you've used for the wait configuration, for example, and make sure it's what you wanted set. If you used a route map to do it, do show access list, remember non-zero. Show IP BGP and the particular prefix, you will see whether or not the wait attribute has been set and what it's set at. And you can look obviously at the show IP route and see that the transits through the next desired neighbor. If you want to verify local preference or multi-exit discriminator setting, again, show access list, show IP BGP, in particular prefix, and make sure you look at either the metric or the local preference respectively. And of course, do the show IP route command. Make sure the next hop address is correct, that the originating router for local preference is correct, and the receiving router for the multi-exit discriminator is correct. And if you want to, you can do trace route to see if it's going through a particular path. In fact, one of the things that's really, really helpful with the trace route command is you can actually note the AS entries along the path, and it'll actually show you what AS paths it's come through.